Hello everybody, welcome to geometry, and more specifically welcome to my living room because I'm not in my office today. It's very exciting. All right, so we are starting a new unit. We're going to start a unit on triangles. There's going to be lots of stuff that you already know, and then we are going to build on that, and we're going to twist in all the equation solving that you learned at the beginning of the year. And you're going to be triangle experts in just a few weeks. Okay, so we're going to start our new unit on triangles, by just looking at angles in general. So earlier in the year, you learned about the different types of angles. We said there's 4 kinds of angles, and we classify them or put them in groups based on how big they are. So small angles, the angles that are less than 90, we call acute. Right? We say they're tiny and they're cute. Big angles, ones that are bigger than 90, we call obtuse. Right angles are kind of like the line in between, right? So a right angle is my 90 degrees. This is a right angle. If it's tinier than that, it's acute. If it's bigger than that, it's obtuse. But I always think of a right angle as kind of the middle. And then last but not least, there's our friend, the straight angle, which doesn't even really look like an angle at all. Okay, that's this guy right here. A straight angle looks pretty much like a straight line, and we know that a straight angle is 180 degrees. Okay, so a right angle we also know is 90. That's going to be really important to us in triangles. Okay, so if, like we said, it's smaller than 90, it's acute. So if you really want to think about the measurements, acute would be somewhere between 0 degrees, which isn't even an angle, and not quite 90, right? 89.9999999 forever degrees. Right? As soon as it hits 90, it's not acute anymore. It's a right triangle. Okay. If you're sticking with whole numbers, somewhere between 0 and 89. If it gets to 90, it's a right angle. Okay. Once it passes 90, though, we call it obtuse. So we can say that obtuse angles are between 90 point... can we say bigger than 90? Somewhere between anything bigger than 90 up to 180, right? Because once it's 180, then it's a straight angle. Okay. So start at 0, acute, 90, obtuse, straight. Right? It goes all the way across. All right. So how are we going to translate this into triangle stuff? Okay. Well, triangles, by their name, have 3 angles, right? So when you're in Sesame Street days, they teach you about triangles. They teach you that triangles have 3 sides, right? That's what everybody always says. Oh, a triangle, yeah, that has 3 sides. That is true. But the name literally is 3 triangles. So what's really neat about shapes in general is that however many sides they have, that's also how many angles they have. I don't know if you've ever noticed that, but like a square, right? A square has 4 corners, 1, 2, 3, 4 angles. If you draw a, what's this, pentagon? 1, 2, 3, 4, 5 angles. However many sides, there's that many angles. Okay, so a triangle has 3 sides. It also has 3 angles. And that's going to be important because one of the things we're going to have to do in this unit is pair up the sides with the angles that go with them. They have like little partners. I'm trying to erase. Okay. All right, so we're going to classify or group triangles in the same way that we classify and group angles. Okay, so there are 4 types of angles. Let's start with the easiest one, right? There's a right angle. If there's a right angle in the triangle, we call it, not surprisingly, a right triangle. Right? So if I see a right angle, if I know for a fact that I have a right angle, then we call it a right triangle. Something else that I know is that if I have a right triangle, I know that these 2 angles are going to be what we call acute, right? Those 2 angles are going to be smaller than 90. One of the fun facts that you learn about triangles very early on is that the 3 angles in a triangle add up to 180 degrees. Okay? So if I know that this is 90, that means there's only 90 left to split between these two. Okay. The other 2 options are, what if it's not a right angle? Okay. If one angle is bigger, if you have one obtuse angle, just one, it's an obtuse triangle. Now, why only just one? Well, if there's only 180 degrees to be had, if one angle is already bigger than 90, like let's say this angle is 180 or is 100 degrees. If this is 100, then that means there's only 80 to split between these 2 angles. So we know for a fact these will be acute angles over here. Okay. So in an obtuse triangle, you're only ever going to have one obtuse angle. Right. Acute, though, if they're all acute, if they're all less than 90, they will all be less than 90. We call it an acute triangle. Okay. So those are your 3 basic ones, right? Either all the angles are little, in which case we call it an acute, or one of them is big, obtuse, or one of them is right. And what's a right triangle? This guy down here is still acute, but he's special. Right? He's very special. He has 3 angles that are all congruent. In other words, the 180 degrees here is split 60, 60, 60. Some people call this a 60, 60, 60 triangle. That's a mouthful. Okay? But this triangle is 2 things. This is a big word. Get ready. Where's my mouse? Okay. One name for this guy is equa, meaning equal, angular, meaning angles, right? Equiangular means equal angles. But something else that this triangle is equilateral. And again, equa means equal. This prefix here means equal. Lateral is referring to the sides. So this means equal sides. And that's both things. It's equilateral and it's equal sides. So if we're talking about the angles of this triangle, we would call it equiangular. If we talk about the sides of it, then we're going to call it equilateral. They mean the same thing. It's the same triangle. Math likes to make things harder than they have to be. Okay, so let's take a look at this diagram. It would help if I moved my floating head. Let me go up here. Ooh, hello. Okay, and let's take a look at this diagram, and we are going to try to classify. We're going to find the triangle that they want us to find, and we're going to put it in one of these groups. Okay, so C, D, E. So here's C, and here's D, and here's E. So we're talking about this triangle right here. Okay, so if you look at this triangle, you'll see that it has a right angle. That's all I need to see. I don't care what the other angles are. All I need to see is one right angle, and guess what? That is a right triangle. Done. All right, so we're going to find the other ones. I'm going to erase that so we can, if I can figure out how to work my pen, I'm going to erase it. Okay, maybe I'm not going to erase it. There we go. Oh. All right, let's get a different color here working. "20 minutes later, she gets her pen working. Okay, the next triangle is B, C, E. So here's B. Boop, 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 boop. Here's C. And here's E. So let's connect those dots and find our triangle. That would be this guy right here. So we have to look at this guy. Do you see a right angle in there anywhere? I don't. Okay. Do you see an obtuse angle? Do you see any angles that are bigger than 90? Okay. Let's look at them individually. This guy looks small. This guy looks small. This guy not so much. That's not an acute angle. That's bigger than 90, right? So one obtuse angle does it for us. That has to be an obtuse triangle. Okay, I'm going to let you do a couple more, and I'm going to switch ink colors because this slide is starting to look a lot like Christmas. And it's like not Christmas. Okay. All right, so take a moment, try those other three, and then we'll go over them. Okay. So, A, B, E, A, B, E, A, B, E. Right? So let's connect our dots here. There's one side, there's another side, and there's another side. So look at this triangle. It's got these little marks in the angles. Right? We learned a while back that anytime things in a diagram are marked the same, that means they're equal, right? So if these three are marked the same, that is an equiangular. Where's my pen? It's equiangular. That is such a big word, right? Equal angles. Okay, let me see. Purple. Okay, we're getting those springtime colors on. All right, let's see. B, D, E. B, D, E. So that's this big triangle over here. I'm going to color it in. All of this. Look at that big boy. Okay, so let's check out his angles. This angle is acute. It's smaller than 90. This angle up here is also acute, smaller than 90. This angle down here, that is not acute. That one right there, it's obtuse. That is bigger than 90 degrees. So BDE has to be obtuse. Okay, and last but not least, CFE. I'm going to clear that diagram so we have some room to really see what's going on over here. Oh, mercy. What do you think about this orange color? Okay, last one. CFE. So here's C, and here's F, and here's E. And it's really important to notice down here, it's not this whole right angle that we're using because this line comes up through here. So our triangle here is just this yellow chunk. Right? It doesn't include this little bottom piece. So we know from earlier that this whole angle right here is a right angle, but this is coming up this way, so it's shy of that. So I know that this has to be acute. If I could spell acute right, it'd be even better. A-C-U-T-E. There we go. All right, over here, angle F, this corner, that's definitely acute. And up here, also acute. So we have ourselves a little acute triangle there. Acute. Okay, so every time we look at a triangle, from now until forever, one of the first things we're going to do is look at its angles and decide which one of these categories it goes in. Is it acute, obtuse, right, or equiangular? Right. Then we're going to give it another name. Right? The first name that we give it is always going to be based on its angles, and then after that we give it another name, kind of like a middle name, if you will. Oh, look what I did. It has two names, right? Its first name is all about the angles. Its second name is all about its sides. So when it comes to the side lengths, there's only three categories. All right. We already talked about this. This is the same triangle we were just looking at, right? Look, 3 equal angles and 3 equal sides. Same thing. On the last slide, we called it equiangular. Here, we're going to call it equilateral. But again, it's the same thing. So we can say also equiangular. So you might come in and call it equiangular, and I come in and call it equilateral. We're both right. Okay? The only thing that you have to be careful of is if somebody specifically asks you to look at a triangle's sides, then you want to say equilateral, versus if they ask you to look at its angles, then you want to say equiangular. But in the end, they're the same thing. Okay, so most of the triangles that we see, right, are going to be like this guy down here. They're going to have no congruent sides. Okay, those we call those scalene. I love that word. Okay, I'm going to animate it in here in a minute, but I'll write it. Then you won't have to read my horrible handwriting. Okay, we call those scalene triangles. Okay, if the triangle has just two sides that match, right? So this has no sides that match. This has a pair of sides. That we call isosceles. Have fun spelling that word. Please make sure you write it down. Every year I'm entertained by the ways that people spell isosceles when they write it. It's I-S-O-S, Celes. This section has lots of big words. So isosceles, and then again, if there's no equal sides, scalene. So scalene if no sides match. Isosceles if you have a pair of matchers, and then if all three match, equilateral. Right. So again, let's go down here and give these guys some names. J, K, M. So in my picture, J, K, M is this whole giant triangle, right? So I've got this side, and this big long side. All right, so let's see. Do we have any sides that match? That's what we're looking for. Okay, this side, the shortest side, is marked with a tick mark. Okay, this side over here has part of it marked with a tick mark, but it has this other part that isn't marked with anything. Okay, so this piece is equal to this piece, but this is a whole big side, right? And then when we come over here to this third side, it has two tick marks here and then another chunk, right? So listen, I don't actually know how long these two sides are, but I know they're not the same. Here's how I know. This one is marked with one tick mark. This one is marked with two tick marks. So that tells me they are not the same. Okay. So we are going to call this scalene. All right. Let's see about this second one. Goodness gracious sakes. Oh, goodness. Hey, that worked better. Okay, let's go with green. All right, KLN, eh? Okay. KLN. So that's this little triangle here in the middle. Okay, so let's take a look at our tick marks. This side has one tick mark. This side has two tick marks, and this side has two tick marks. Ding, ding, ding. So look, these two are equal. Where's my pen? These two are equal. They both have two tick marks, but this guy is decidedly not. Now we can visually see he's not, but also we need to pay attention to those tick marks. These two sides are matching, and he is not matching. We know for a fact he's not matching. So if we have two sides that match, that's our friend isosceles. Sounds like a Greek philosopher. Okay. All right, last but not least, even though you're probably saying, Miss Britton, we know it's going to be equilateral because it has to be, right? It's the only one we haven't done yet. Well, you don't know. You don't know. Let's see, JKN. JKN. There's a side. There's a side, and there's a side. So let's see, one tick mark, and one tick mark. And once again, math becomes predictable. Here we go, 3 equal sides. It is equilateral. Equa means equal. Lateral is referring to sides. Okay, so what we want to be able to do when we look at triangles is, again, give them two names. A name based on their angles and a name based on their sides. So we're going to do a couple of those together, and then you're going to do some on your own. All right, we take a look at this first triangle. If we name it based on its angles, I just need to see how big they are. I've got an acute angle. I've got another acute angle. And I've got a third acute angle. Acute, acute, acute. That is an acute triangle. All right. If we label it based on its sides, we give it a name based on its sides, we need to figure out if it has any sides that are equal. Now, notice in these ones there's like some tick marks involved. Okay, there are no tick marks here. It's got nothing equal. Right? So if none of the sides are equal, we say it is scalene. So we would call this an acute scalene triangle. It gets both names. It's acute scalene. All the angles are small. The three sides have different lengths. It tells us both things about it. Okay, it's possible to have an obtuse scalene. Right? So we're a right scalene. So we have to make sure we give it both names. All right, let's look at number 2. When it comes to angles, I see an acute angle here. I see an acute angle here. And right here, I see, oh boy, an obtuse angle. That's a big boy. All right, so I know my triangle is obtuse. Let's look at the sides. One tick mark, another tick mark. I got 2 that match, no tick mark. So this guy doesn't match. Again, we can see he doesn't match. 2 tick marks. That means isosceles. Isosceles. Okay. So this triangle we call obtuse isosceles. Obtuse, it has a big angle. Isosceles, it has 2 sides that match. All right. Last but not least, we have our friend over here. If we look at his angles, that's acute. That's acute. This is not acute. This is a right angle. It's marked with that square. So I know that this triangle is a right triangle. Now I just have to name it for its sides. So let's check them out. Tick mark. Tick mark. I got a pair. Third side, no tick mark. So this is right and isosceles. Okay. All right, so there are a couple problems in Schoology that I would like you to go do. You are using drop-down menus to classify a triangle. And you're going to say, this is acute and scalene, or this is obtuse and isosceles. I couldn't remember the word. All right. So you're going to go fill those in, and then we will talk tomorrow. Have a wonderful day.